Hello everyone, my name is Grace Jin. Today is the first class of machine learning in civil engineering. Before I start, I want to first talk about, as civil engineers, why do we need to learn machine learning? This is because we are living in a fast-changing world. It's demanding different skill sets than the ones that were expected just a decade ago. Right now, an increasing number of industrial companies, both large companies and small companies, they are using enormous amount of data for analysis. So data science techniques are used as a problem-solving tool to tackle the various problems in civil engineering, such as structure failure prediction and material structure optimization, etc. And this, in turn, has made data science programming as part of the required skill sets an employer expected from a new engineering graduate. So in this class, we will talk about three different areas. First, programming and graphical visualization with R. And the second, mathematics basics of machine learning techniques. And the third, I will present a typical problem to demonstrate the application of data science techniques in civil engineering. Machine learning techniques include many different types. So we will talk about maybe 7 or 6 different techniques, including k-nearest neighbors, support vector machines, artificial neural networks, etc. Upon successful completion of this course, the students are expected to be able to develop simple programs within R environment and also use data science techniques as a problem-solving tool to tackle practical problems in various areas in civil engineering. So we know that machine learning is widely applied in many different areas. So, for example, it's used to identify the spam messages in email. And also it's used to create targeted advertising based on the customer's behavior. And it's also used for weather forecasting and long-term climate change prediction. It's also used to reduce fraudulent credit card transactions and to estimate financial damages from storms or natural disasters. It's also used to predict election outcome or to develop algorithms for self-driving cars or drones, or it's used to optimize the energy use in a house or in an office building. It's also used to predict which area the criminal activities are most likely, and also used to discover the genetic sequences linked to specific diseases. Okay, so let's start from the basics of machine learning. So first I want to talk about the input data. There are some terms, for example, unit of observation, feature, example, categorical, nominal, and ordinal. So what do they mean in machine learning? So first, the phrase unit of observation is used to describe the smallest entity with measured properties of interest for a study. It can be persons, objects, transactions, or time points, etc. And the data sets they are used to store units of observation and their properties. So for example, the data in this matrix is used as a data set for machine learning analysis. So the format of the dataset is often in a matrix format. So we have row and column. So the rows are usually called examples, and the columns are usually called features. So each column corresponds to one feature. So for example, in this table, you can see obviously the unit of observation is cars, right? So we have the year of production, the model of the car, the price of the car, the mileage of the car, and the color of the car, also the transmission, it's auto or manual, right? So each car is one example in this data set, and so each column corresponds to one feature of the data sets. Okay, so now we know the unit of observation, the feature, and also examples. So examples are instance of unit of observation, and the features are recorded properties or attributes of examples. And they are often presented in a matrix format. Okay, so for example, if I want to build a machine learning model to identify spam emails, so the unit of observation will be email messages, right? And the examples will include many specific individual messages, and the features will be the subject, the date send this message, and also the length of the message, etc. So as another example, if we want to build a machine learning model in order to study to kind of detect if a person get cancer, then the unit of observation will be patients, and the examples will include many different samples of cancer patients. The features will be their genomic information, their weight, height, blood pressure, etc. Okay, so I hope right now you know what's unit of observation, what's feature, and what's example, so that if I give you a matrix, you can understand the information you have. Okay, so you can see in this table, we have some of the feature is presented in numbers. So so we have different forms of feature, right? Some of them are presented in numbers and some of them are not. So for those presented in numbers, they are called numeric feature. And for those are not in numbers, they are called categorical feature or nominal feature. And this categorical feature is also divided into ordinal feature or non-ordinal feature. So for ordinal feature, it's a special category of the categorical feature. They have a order in it. So for example, the clothing sizes, we have extra small, small, medium, large, and extra large. So you can see there is an order of these different clothing sizes. So this is the ordinal feature. For example, the colors of the cars, they can be yellow, gray, silver, white. There is no order in it. So these are a non-ordinal feature. Also, for example, when you fill out the teaching evaluation, you will have a scale, right? From not at all happy, somewhat happy, and to very happy. So there is an order in it. So this will be ordinal feature. Okay, so these are the different types of features, and then we can talk about different types of machine learning algorithms.